Hi, and welcome to the snowless island of Advent of Code 2023. It's day 3, and let's see what's going on. What is our today's task? Yeah, it's here. Before reading it, I'd just like to say a couple of words about yesterday's task. So yesterday I did it in Python. It was my second day, and it was pretty decent, and now I'm finally confident enough to try to do it in something like Haskell. So, let's read the task. Geo ratios. You and the elf eventually reach a gondola lift station. Gondola lift, what does it even mean? Okay. He says that the gondola lift will take you up to the water source, but this is as far as he can bring you. You go inside. That's some strong text quest vibes. It doesn't take long to find the gondolas, but there seems to be a problem. They are not moving. You turn around to see a slightly greasy elf with a wrench and a look of surprise. Sorry, I wasn't expecting anyone. The gondola lift isn't working right now. It'll still be a while before I can fix it. You offer to help. The engineer explains that an engine part seems to be missing from the engine, but nobody can figure out which one. If you can add up all the part numbers in the engine schematic, it should be easy to work out which part is missing. Okay. The engine schematic, your puzzle input, consists of a visual representation of the engine. There are lots of numbers and symbols you don't really understand. Fair. But apparently any number adjacent to a symbol, even diagonally, is a part number, and should be included in your sum. Periods do not count as a symbol. Okay, yeah. Here's an example engine schematic. One thing that I learned is that it can be useful to just take this and actually make into a sample to test your code on. So let's go here. Let's make a directory for the day 3, and let's just get it into example dot input example1 txt. Yeah, it's here. Okay, in this schematic, two numbers are not part numbers because they are not adjacent to a symbol. 114. Yeah, it doesn't have any symbols around it, except the dot, which is like a white space, and 58, middle right, yeah, here it is. Every other number is adjacent to a symbol, and so is a part number. Their sum is like this. So you have to take this one, you have to take this one, this one, this one, not this one. This one counts. This one counts because of that star here. And this one counts too, and this one counts too. Okay, their sum is blah blah blah. Of course, the actual engine schematic is much larger. What is the sum of all of the part numbers in the engine schematic? Perfect. So we need to read the input, we need to parse the numbers, and we need to understand if numbers actually have any non-empty cells adjacent to them. Okay. Now I get my input, which is, today I learned that it is customized for me, and yeah, that sounds pretty good. Oh, not like this. Can just copy, can paste it here. I hope it won't botch anything. Okay, yeah, let me just clean up the last line that I added accidentally. Okay, and now what do we need to do? We need to classify the numbers into First, we need to find the numbers, and then we need to classify them if they should be added to the sum. Okay, and then we need to output the sum. Okay, yeah. Whew. Yeah, so my bold plan was to do it in Haskell, and yeah, I'm starting to regret it because it's kind of a 2D field, which would be perfect for a 2D array. And actually, many tasks here are tend to involve arrays and just index manipulation and so on and so on. But yeah, it's not like we have to be perfectly efficient space-wise, and could we just use some kind of a map? We also need to be able to address the neighbor cells quickly, so maps do that. Oh, actually, I could just use Haskell arrays, Haskell vectors. They give you some pretty decent indexing, and I don't actually need to mutate them, to change them. The only thing is that if you run, do I have stack GHCI? No. Well, yeah, Haskell setup might be not trivial. GHC up, show, run, GHCI. Okay, it doesn't exist. Okay. Yeah, it's been a while since I did Haskell. No such file directory. Oh, right. Yeah, it looks like it will be a while before I can run anything. Yeah, Haskell tooling sucks. Do I really need this stuff right now? Oh, no, I am not compiling anything right now. Okay, so we have to get by with what we have right now, which is what? We have GCI in there, we have stack in there. Oh, okay. So I'm starting to remember. That should suffice for us for now. And actually, let's run tmax because I cannot live without it. Yeah. Let's go here. Let's do the same good thing. Let's ask which is stack, which is GCI. Should I do stack init right away? Yeah, I think it's a good thing to have. Okay, stack init help. What does it do? Oh, and then what? Okay, what do we have here? Just a bare stack YAML. Okay. Packages. Oh yeah. Can I do it like this? Main HS. Hello world. Stack one. Oh, not that crap again. Okay, we'll have to wait. I'll get back when it's done. Yeah, and I am back. Yeah, so I had to remove the stack project and I had to update everything Haskell related, and I just did cabal init interactive, and then some massaging, trying to understand what do I need exactly, and finally I have cabal clean and cabal run, which does very simple thing. Hello Haskell. Yeah, okay, now we can solve the task. So, first of all, I'm wondering if I can run GHCI. I can. Do I have data array or vector or anything like that? Yeah, I do have data array. I don't have data vector, which is not good. Do I have any data? Yeah, map is here. Int map is here. Okay, so that's what I have. Yeah. So, the first very simple subtask that I can do is to parse the file, and that will be actually expand top, sts2, shift width, yeah, 2. Okay, so we need to parse the file, which is an input, for example, or not. So let's import system, what was that, env, environment. Yeah, and this one default of qualified if you want to not pollute your namespace. Just why? Okay, env dot get, what was the incantation in there? GCI qualified, no, not system environment is env dot, yeah, I remembered correctly, it was get args, but for some reason I cannot get it working here. Okay, that doesn't matter much. So we got our arguments, which are, oh, again, we don't have the language server. Oh wow. HLS. Oh, it's Haskell language server. Okay, wrapper. Okay, yeah. And now I have to configure my NeoVim. Okay. LSP. Do I have anything about Haskell? No. How do I configure it? First analyzer setup. HLS setup. I do have it. Why are you not happy? Executable we failed to find. Try to restart. Okay. It's in GC up bin. Yeah, it has a lot of stuff in it. Haskell language server. But why? Okay, I can just quickly make it work. I will regret it later, but that's not what I want to do right now. Haskell language server wrapper, and I want just, oh, it's the other way around. I just want to link Haskell language server wrapper to Haskell language server. What are you even doing? Let's change the admin. So now we have this thing. Let's remove bin Haskell language server 2, which is just a symlink, stupid symlink. Oh, yeah. Does it work now? Oh, that's what Haskellists need to be happy. Just language server finally working in their editor of choice. hover is not supported by any of the servers registered for the current buffer. Are you kidding me? Omni completion does nothing. LSP info. Does it work? No, it doesn't. Okay. LSP start. Is there anything happening? No. Okay. Cobble build. Why do you even need the source? What the hell is happening? And now you need it in source? Ooh, failed to build. Why do you need both app and SRC? Why do we need two different folders to have a simple hello world? Wow, yeah. Wow. So now we have to have it in main HS. Wow. Main. At least something works, and it runs the app main. But if we nuke, let's not nuke it, but just save it. If we try to do cobble run again, if we try to do cobble clean and cobble run, okay, so it only needs the app main. Okay, yeah, that's what I thought, but it was really weird. Okay, so what can we do? First of all, I would like to take the name of the file from the environment, from the process arguments. Oh, it's not data, it's system. Oh, finally, I have completion. So it's not good, but it works sometimes. Get. Why the hell? Args cobble run. Yeah, and if we run it with input.txt. Oh, that's not what cobble run means. Okay. Oh, so how do I pass arguments to the executable? Oh, okay, I don't care. This new style, do we have... Oh, shit, why do you have so many folders? Wow, I have Windows flashbacks. Finally, I have found my binary. Just 1, 2, 3, 4, 5, 6, 7, 8, 9 levels deep somewhere. Ooh. Not cool, not cool. Yep. Cobble run. Test. Oh, okay. Let's try to look at it again. Come on, that's not how good utilities look. They should not spit a few pages of obscure options at you. That's not how it works for people. Okay. I think I'm just... Does VS Code help me in this case? I will still need to run it with arguments. What a pile of unusable crap. At least stack was a little bit more humane. Okay, let's hope for the best. Failed to execute the build plan. Okay. What the hell autogen means? It's listed in the Cabal file but does not exist. Так, okay. SRC, library. Can I not have a library? Cabal build. Cabal. Finally. Wait. Stack build. Stack run. Stack run. Cool. Now that what humane utilities should look like, because Cabal is just atrocious. It's still atrocious. They never learn. Okay, so now that we are done with this headache, let's actually solve the task. Yeah. What does it run actually? Main? Yeah, this one. Okay, let's go back and get args. Okay, how do we read the file? Let file path is head args. But that gives us the string, and we can try to open that file and that we can read it. So yeah, let's refresh my memory. System IO, it was in system IO, I believe, as IO. Was it read file? Yeah, it was. So if we can just slurp the contents of the file with read file path. Let's just quickly try to print it back just to see if we actually do this right. Oh, it started warning about partial functions. I like that. Not that it matters in this case anyway. Not Cabal be damned. Stack run. Input. What? Yeah, I do have input x1. Stack run. Input x1 txt. It builds and it reads a file. That's how we read a file in Haskell. Only 25 minutes of fiddling around, and yeah, now you have the file. Good. Now that we have the file, we have the characters of each line, and we can start actually parsing it and putting it into some data structure. What this data structure be like? Again, let's fiddle in the REPL. Import just to have it close nearby. Yeah, it's here. And let's do the same with input file input x1.txt. Wow, it completes it. Let's look at input. Yep, that's good. What we can do now? So if we do lines input and map it with not words. Okay, so now we have a list of lines, and do we have any kind of enumerate? Yeah, that's not how to do it in Haskell. You need a range. Okay, now we have numbered lines, and now you can map over it with something that annotates each character with a tuple of coordinates, and that will be zip width. No, zip width just takes both parameters and gives you a callback, a function, a parameter which actually produces the zipped value. So I still need to, first of all, I still need to map every element of this list, and every element of this list is a tuple of the index and the content of the line. So now I destructure it into I and S, and I can do, and now I can enumerate the internal indexes, and that will be like, since S is just a string, I can actually do this. Oh, and what I actually want to do is zip width. So I got my J and a character, and now I want to produce a pair of a tuple of the coordinates and a character, and it blows up in your face. So what am I doing wrong? Did I get the type of zip width wrong? Type of zip width. Okay, let's look again. So, okay, yeah, I see now. It doesn't take a tuple, it takes two arguments actually. Oh, that's what it is. Okay, and now we have basically enumeration of every character in our input data, and we have their coordinates here. Now let's just put that into a map. What do I call it? field map input data. Whatever. That from list. What is happening again? Oh wow, that's a list of lists. Yeah, so I need to flatten it. How do you flatten it? Yeah, maybe just flatten. Okay. Now I need even more helpers. So, help. How do you do flat map again? Okay, my mind is blank. Nothing jumps at me. L concat. Oh yeah, right. L concat. Yeah. That's what I need. Okay. Weird Haskell naming bites me again. Okay, and that will be something that can be used for map from list. Type checks out. Data. Go in. Perfect. Yeah, it's a bit tiring actually to just do that twice basically. Why doesn't my mouse work now? Oh, okay, because I was not there. Okay, so now we have this weird thing, which will be our, I won't call it map, I need to call it good name, fields. Run. Reload. Well, maybe I have to do it like this. Oh, yeah, now it works. Import qualified data map as M, as an uppercase M. Are you kidding me? Hidden package, right? Where do I edit stack YAML? Or is this in here? Dependencies. Executable build depends. Oh no. Containers. Yeah, it's not a string. Finally, it is doing something sensible. And can I domain now? Exception. Yeah, because I did not give it the file. Yes, that's how I did it. Okay, now So if I look at the map, what do we need to get again? We need our So, first of all, we need to find numbers somehow. We need to combine digits somehow. We need to combine them into numbers. And we need to check that any of the neighboring cells in there are actual parts. So, yeah, let's do that. So, let's make this a little helper to have more types, but yeah, it's not strictly needed anyway. A map from int into character. Parse is all that stuff. Parse what input, and now parse input, and now it seems to work. Okay, now do we just iterate over the example, and if we find any digits, do we just fold them? And also, do we just fold if any neighbors can and also we have to check all of the neighbors at this moment. Okay. That's not a trivial kind of iteration that I need to do right now. Should I just try to write it down in the state of the iteration? Oh, state. So, what will be our state? I don't know yet, but let's they called it schematics, right? Let's call it like this. Data. Solve data into int, basically. Solve that. Solve that. Solve that. Not underdefined, undefined. Yeah. Now print solve parse input. Reload main input example 1 call stack undefined. That's what I expected. Yeah. Now what? Now we need to fold it. What would be a good way to do it? I need fold left because I want to fold it from left to right. Yeah, I really don't know which fold I need in this case. But let's assume this one. Interesting. Oh, map folder. Oh, yeah, actually, that's a map, so that's good. Yeah, yeah, yeah. Oh, folder. The first argument is the iteration function. The second argument is the initial state. Let's call it st0. And what else? And then we need the map that we want to iterate on, which is that. And now let's draw the rest of the whole. So st0 is state, goal is state, and what? Oh, fold with key. Yeah, I do need keys. Key A. Do I have foldle with key? Yeah, I do. Why? Why do you do this? Why you put element before? Oh, it's state, it's the key, and it's the value. Okay, it makes sense now. Foldle with key. I even have completion for now, which is a miracle. Yeah. Character. Okay. Undefined. Could I mesh type int with... Oh, right. Yeah, it takes them separately. I still am thinking in terms of tuples. Failed, no modules loaded. Because... Alright, yeah. Result is int, and here result, how do you say that? Is this like this? And here you do result of this folding. Okay, now it works. It just doesn't run yet. Yeah, it blows up here. Okay, now what? So we have our whole map available because it's just a closure and it's in scope. So we can ask for neighbor cells for each cell. So let's see. Case C of. What can be our cases? It's a dot. Do we do anything? I really don't want to use the short names, but yeah, it looks like I have to int. And I also have to initialize it here. Oh, and it really needs to be a maybe, because I am not always handling an int. And yeah, I think it's nothing at the start. And now what? So the next state is current number becomes nothing again. Oh yeah, that's some Rust sleeping in here. What else can we have? Anything if this is C. Anything if C is digit C. In this case it's undefined for now. And anything else is also undefined for now. Okay. Okay. Is should state be like this? So we have a result, we have the current number. Should it be like this? Type is what was it called? Part number is bool. Is part number maybe int? No. Maybe all of that. Yeah, it's starting to look bad. Okay, so if we see a digit, then what do we do? Match current number state. Oh, not match case, obviously. Of if it's nothing, then what state are we in? We just encountered a new number, and we need to put it in the state, and we need to check if it has any part neighbors. Okay, we need a helper. Has parts has adjacent part, and we take an index, and then what do we do? Again, let's do a quick trick with the convolution window, which will look like this. It will be a constant of let's just call it neighbors, and it's a list of int coordinates, and it's basically the first neighbor lies here, the second one here, another one here, then we have the same line. Wait, this one is not needed, but you have to look left and right, and then you have the same but with one line below, and that gives us 8 neighbors. Yeah, and that is a good constant that we can use here. Let's reload. Oh yeah, it must have been defined to be able to reload. Oh yeah, undefined. Visitors and part undefined. Oh right, that's not how you spell functions, function definitions. And now, so we have this function any, which takes a predicate and something that we can fold on, and it answers if the predicate holds for any of the neighbors. In this case, what do we want to have? We want to address the map using this function map lookup and neighbors. Okay. Input. Okay, let's write it once and for all. Yeah, parse applied to read file input x1 as a functor. Let's look at our input and let's promote that to a high level definition, top level definition, and it has a dot, which is a, what was that? Then was the coordinate, and then there was a bool. Okay, let's reload. Yeah, now we have to collect our data again. Has adjacent part input 0, 0, and yeah, now we just have to implement that. So first of all, we take neighbors and then we map them with what? Yeah, I don't want to be yeah, DJ DJ, yeah. Let's say we take 4 plus di, 5 plus dj, and that will gives us the list of the coordinates. Good. Map. That's not how to do it. Whatever. I j plus j plus dj. Neighbors. It's still this one is still undefined, but let's just put it into the scope. So neighbor coordinates, how do you call it? Neighborhood. Indexes. My brain is starting to slow down. I'm just bugging in the details. How do I call it? NIDs, yeah. I don't care. Okay, used by map. Why not? Why not use a bifunctor? Why not use a bifunctor? Thank you, Haskell, thank you. No, I prefer my simple code. Okay. Now that I have the coordinates of the neighbors, I need to I need to take the coordinates and I need to map over them, NIDs, and for each coordinate I have to do what? We have our map and we can look up in that what ij in that map. Let's call that P point. Yeah. And this expression gives us a maybe over character. And now we have to translate that into if it's a part or not. So we have this helper maybe, which can take a maybe value, and in case of nothing it uses this value, and in case of something, what is it called in Haskell now? Just. In case of just, it just applies this function. So if we got nothing from the map, then no, we don't have an adjacent part. If we got a character, then we have to check if this character isn't a dot and isn't a digit. So basically is part char to bool part c is defined as, first of all, it's not a digit, and do you remember that right? Yeah. And it's not, and c is not equal a dot. Yeah, something like that. And then we can just supply this helper is part here, variable not in scope, char is digit. Wait, what? Oh, I called it c for brevity. Yeah. Okay, what do we have now? A type error has a JSON part. It must return what? What was the predicate for booleans, which just take a list of booleans and tells if any of them is true? This one uses a predicate. Was it and? This tells if all of them are true. So what we really need is or. So or false, true. That should be true. Right. And then we just or them together. Use any. Oh, yeah, actually, yeah. So or actually can be defined as what was that again? Any map? Yeah. So that's how it can be defined. Yeah. Now, can we make this into a helper? Has so what does this do? So it takes a coordinate and produces a boolean which tells it if this coordinate is a part. Oh, I wish Haskell had namespaces. That's a nasty clash. Part. Can I just inline that? Okay. I just need it to work. That's all. So we get a character and we apply a lambda to it, and that's it. And we don't care about this. And we just use isPart as this helper. Okay, reload. Yeah, it type checks. So let's test it. Input. Let's read the input again. So let's look at the input, and that was a bad way of looking at the input. Okay, so if we ask about this point, or for example this point, which is 0, 1, 2, 3, 4, 5, 5, 0. If we ask has adjacent part input 5, 0, then yeah, we get false. If you ask about 4, oh, that's not right. 0, 1. Oh, wait. Actually, I was looking at 0, 1, 2, 3, 4, 5. And yeah, it makes sense that neither this one, neither this one have a part nearby. So if we look at 1, 0, 1, 2, 3, it's true, it's false, it's true. Okay, it looks like we have I have a working building block. Okay, now that I have a has adjacent part, what I can do? First of all, in any case, if this is a digit, maybe it's part number. That's not a very good name, but anyway, has adjacent part. Who? The map is dot, and the point is ij. In. Did I just break the indentation? Yeah, let's indent it just to be sure, because in Haskell you never know if this is the right indentation. Really, I don't know. This should be. Okay, case number of nothing. So what do we know? We know that we encountered a digit. We know we have checked if it has a part nearby, and we can proceed. So we keep the result. Actually, to make my life easier later, let's just update the st that we got here. I wanted to highlight it, yeah. So we won't touch the result yet. but we need to update the current number to just the first thing is part. The second thing in the tuple is the current number. And how do you read a number from a character? So 1, and let's give type int. It really wants a string. Okay, read C. Okay. Yeah, Haskell, it's safe to use git here because it is just a digit. It cannot be anything else. Okay, if we had previous is part. And we had what, some number already. Then what do? We update the current number to just what, okay, I also need this. I also need to read this digit value, and this will be like this. And okay, is part or oh yeah, that's just really inconvenient. So I updated the current is part, and what happens with the number? So n gets multiplied by 10, and the digit value gets added to it. Phew! And now we handle the numbers. And I think plain if would be better here, because the first case is if it's a digit. We can just move it here. And then we do else. Else. So what happens otherwise? Again, we need to deconstruct the current number, st, and in case of nothing, we do nothing, we go ahead. In case of some, just is part 0. Why do I have to do this? These useless names that I just have to invent and just have to hold in my head, just because. Yeah, point freestyle has a point. Sometimes. But yeah, sometimes the cure is worse than the disease. Okay. Case current number of just is part 0. Okay. What happened here? First of all, we are outside, so we left a number. We know the number, we know if it was the part. So basically, if it was a part number, then the state becomes the state becomes updated, and it is updated to some ridiculous thing like, oh, let's compute a new result. Let result, but then I override it. Why? Haskell, why? Plus n in what? State where result becomes r, else we do nothing, we just go ahead with the state that we had. Oh, no, we still need to update the current number to nothing. Okay, and here what happens, so it was, but we need to update the current number to nothing. Oh. Okay, let's make this a little bit better. If what is part, then else just the result of st. We need to keep the in, and we need to update the state. Does this look right? What do we do with parts? Do we care if the current cell is a dot or a part? No, here it's okay. Yeah. Main exam. Yeah, no, let's repeat input. And then solve input. And is this the answer? Yes, it is. So, wow, that was it? I don't have to debug anything? Okay, let's repeat this. Okay. This is a moment a bit of like a Russian roulette, because this is the right answer. Whew. Well, that was interesting. When you code Haskell, you have to put up with so much small nuances. But then you just run it and it works for the first time. And I don't know how to describe this. Yeah. On one hand, you have to suffer through all of this upfront pain of just setting everything up, just writing some silly things, writing some gibberish like this, just trying to model your way through these compiler errors, but then you just run it for the first time and it just works. Okay. But it's not like it was not this way with Python yesterday as well. So, okay, maybe there is nothing gained, actually. And actually, I don't find this code readable. Just look at that. Look at that. That's horrible. I can put some lipstick on a pig, just giving this some names. like this. Index lines. And then I could put more lipstick on the pig, saying indexed characters. But it's just this is just isn't fun. Data types is none. Oh wow, they actually recommend making this strict now. Expected strictness annotation. So where should it go? Here? That doesn't even parse. So how do you put strictness annotations? It's not Cabal. Let's not mention Cabal again. Build. Okay, that's just some linter being overzealous. Okay. Okay, I think that's enough for one video, and I will get back with the second part.